All right, welcome back. So now we get a little bit more complicated because not only are we going to have to deal with graphing our parent function and then the stretch of the function, but then we're also going to have to deal with the shifts as well. So I'm going to write down that order for you again real quick. The first one is always going to be the parent. The second is going to go ahead and be what we go ahead and we shift it by. So step 2 is not the shift, we're going to stretch it by. And then the third one is going to be what our shift is, okay? So let's go ahead, let's just look at this. The parent graph we're going to have is y is equal to 2 to the x power. So points that I'm going to have there, notice I'm counting by 2's for every 2 blocks. I will have the point 0, 1. I will have the point 1, 2. 2 to the second is 4. 2 to the third is 8. 2 to the fourth is going to give me 16. So that is 10, 12, 14, 16. And then I'm going to come down the other way. I have 1/2, 1/4, 1/8, etc. So this is my parent's graph here. All right, step 2, I am going to go ahead and do the stretch. I'm going to multiply all those points by 3. So it was at 0, 1, now it's going to be at 0, 3. It was at 1, 2, now it's going to be at 1, 6. It was at 2, 4, now it's going to be at 2, 12. So 4, 6, 8, 10, 12. It was at 3, 8, now it is going to be at 3, 24. So this was 12, 14, 16, 18, 20, 22. I'm out of room there. That's fine. This one was at -1, 1/2. So now it's at -1, 3/2. We were at -1 or -2, 1/4. Now we're at -2 and then 3/4. And it's still going to go ahead, it's still going to approach that x-axis. So we've taken care of the stretch, and now we've got to go ahead, we've got to take care of the shift. We are at 2 to the x minus 1 and then -4. Keep in mind when it's the x minus 1, anytime it's in a grouping symbol, anytime we were dealing with like the quadratic or we were dealing with an absolute value, it was the opposite of what you would think here. If x minus 1, we're actually moving to the right 1, and then it's the same thing as what we would see outside. We are moving down 4. So each of these points here, we're going to now move. We're going to move over to the right 1, and we're going to go down 4. So 1 to the right, and then 1, 2, 3, 4 down. Starting here, 1 to the right, and 1, 2, 3, 4 down. 1 to the right, and then 1, 2, 3, 4 down. We were at 1 to the right, 1, 2, 3, 4 down, 1 to the right, and 1, 2, 3, 4 down. So if we go ahead and we graph this now, this is my y equals function. I've gone ahead, I've taken care of the stretch, I've taken care of the shift. Here is my y equals function. Now the domain did not change. It was still x such that x is in the set of all real numbers. The range, however, it did change. Okay, notice I now do have some y values. It goes all the way down and it approaches -4. Take a look. This value right here, this is going to tell you what your horizontal asymptote is going to be at. It's also going to tell you what all of your y values either need to be above or below. So since it's all above that -4, I can say that we have y such that y is going to be greater than -4. It's never actually going to hit -4, which is why our horizontal asymptote is that y is equal to a -4. All right, let's go ahead. Let's flip it over. Let's look at number 7. I have y is equal to negative 3 to the x minus 2. Keep in mind this minus 2, that's going to help me out with the horizontal asymptotes. I'm going to put that in right now. Y is equal to negative 2. I'm also going to put in the domain x such that x is in the set of all real numbers. And now let's work our magic. So the parent function that I have to deal with here is going to be y is equal to 3 to the x power. So I have the point 0, 1, 1 to, and then 3, because that's 3 to the first, 2, and then 3 squared is going to give me 3 to the 9th, and then 3, 9. So that is 2, 4, 6, 8, 9, and then 3 to the 3rd power. That one's not going to actually work for us. That's fine. Going the other way, I'm going to have 1/3. I am going to go ahead and have 1/9. So this was the parent function. Now we take a look at the stretch. What we were multiplying it by, we were multiplying it by a negative value. So what that's going to do is that's going to reflect that over the x-axis, which means I now have the point 0, negative 1. I have the point 1, negative 3. I have the point 2, negative 9. And then I have negative 1, negative 1/3, negative 2, negative 1/9. So there is the second part. And now I need to take a look at the shift that I need to do. I'm not adding or subtracting anything to the x, but I am moving all of those points down 2. So again, I like to start at 0. So 0, negative 1, we move that down 2. 1, negative 3, we move that down 2. 2, that was negative 9, we'll move that down 2. And then we'll move each of these guys down 2 as well. So I've got something that looks like that. So I like to do the range part second then, or actually last, because I now have to take a look at that graph. Notice that all of my values, they happen to be going down here. They are all below my horizontal asymptote. So I'm going to go ahead and say that this is y, such that y is going to be less than negative 2. Okay, so process again. We do the parent, we do the stretch, and then we go ahead, we do the shift. Now, the last thing that I want to go ahead and talk to you guys about is a number called E. Now, you may be saying, did she make a mistake again? Nope, I didn't. E is actually a number that we're going to talk about, all right? And it says here that many problems that occur in nature require the use of an exponential function, whose base is a certain irrational number. Like pi, which is an irrational number, the number has its own symbol that happens to be the letter E. And what I want us to do is I want us to use the graphing calculator to approximate the value of E. So what I'd like you to do is I'd like you to go into your calculator, into y equals. Let's go ahead and right above, if you look at on and then store and then you see this ln, right above the ln button is the e to the x button. So go ahead, hit second, ln, that'll give you the e, and then type in x. And let's go ahead, let's graph that. That gives me an exponential graph. Now if I want to find some points to go ahead and to plot here, keep in mind this is an irrational function, which means none of these numbers are going to be pretty for us. Let's go ahead and let's plot what we can. We have the point 0, 1, which that one should make sense to us because anything to the first or to the 0 power will always go ahead and give you 1. We have the point 1, 2.7183. So 2.178, that's right about, not there, that's right about here. we have the point 2, 7.3891. So 2, 7.38. And then we know that these guys are going to go somewhere down like that as well. All right? Because all E is, again, it's just a number being raised to the x power. Now, what is E approximately? Let's think about it again. Every exponential function will pass through the point 0, 1, and it will also pass through the point 1, b. In this case, our b is the E value. So if we were to take a look at the point 1e, well, let's look there. 1e, what is E approximately equal to? E is approximately equal to 2.718. Now we're going to deal a lot more with E, but not today because Delzati is done, so I will see you in class.